Hello viewers, welcome once again to Quest, the inter-school science quiz brought to you by Doordarshan Kendra Kolkata and the National Council of Science Museums. Through a very interesting and educative series of experiments, we show you a behind-the-scenes look at how things actually work. Conducting the experiments and asking you very interesting questions all over again, we have, and I want you to welcome him with a very loud round of applause, Dr. Jayanta Sthanapathy, the Director of National Council Science Museum's headquarters. Welcome, sir.
Hello.
What do you have in store for us today, Dr. Sthanapathy?
Many experiments.
Many experiments?
But not with balls this time.
Well, last week you had this fascination with spherical objects. Okay, moving on. We'd like to begin with introducing the teams to you. On my right is the JCB team. That's the boys from Patha Bhavan, Kolkata, and they are?
I'm Abhimanyu Kaur.
I'm Shomo Moitro.
And hello, I'm Indranil Goswami.
Have you ever watched our show on television?
Yes, sir.
I'm sure it's already your favorite science quiz, is it not?
Yes,
Yes.
sir.
And on my left is the CV Raman team, and you are?
I'm Tathagata Sengupta from BD Memorial Institute.
I'm Arnab Gupta.
I'm Apratim.
Let me familiarize you with the rules of today's contest. 7 questions in all. First 4 are direct. 20 points for every correct answer, irrespective of whether it's on the buzzer or it's direct. 10 points for questions answered on passes. In the buzzer rounds, remember the last 3 questions are on the buzzer, plus 20 if you get it right, minus 10 if you do not. Also remember that whenever you're ready with the answer, you should only then hit that buzzer, because once you press the buzzer switch, we will ask you to answer irrespective of whether or not the question's been asked. Anyway, enough of the preliminaries. Onwards now to the very first question, which is for the team seated on my right, the JCB team, Dr. Sthanapathy. And now the very first experiment. JCB team, I hope you are ready.
I have 2 identical inclined tracks here. This is one and this is the other one. They are identical. And also I have 2 apparently identical, I repeat, apparently identical 2 objects which are nothing but wheels. I'll put one wheel here at the topmost point of one channel and the other wheel on the topmost point of the other channel, and let them roll. I'm repeating it once again. The wheels are placed at the topmost point and allowed to move. One wheel which is in my left hand is faster than the wheel which is in my right hand. You can watch these wheels closely.
Yes, sir.
And tell me why this wheel is moving faster.
The wheel on your left hand
Yes?
has some button-like weights,
Okay.
and the wheel on your right hand also have button-like weights, but these weights are farther from the axis.
Okay.
Now, the 2 wheels have different moments of inertia.
Very good.
The wheel on your left hand have lesser moment of inertia, and that is why it is rotating faster.
It has?
It has lesser moment of inertia.
The buttons on the wheels of the left hand side, left hand has lesser moment of inertia, and we know that as the moment of inertia of the wheel of some kind of weight, of some weights are less, then the angular velocity will be much more.
Yes, that's the right answer. Okay, you get full marks for that.
Well,
Over to Gaurav.
As you can see, both Abhimanyu and Shomo both tried to make the wheel of fortune turn in their favor. Well, one thing we know is that they have picked up 20 points. Let's have a big round of applause for them. Dr. Sanapati, I'm sure you can throw more light on the matter.
Yes. Now, in these two wheels, the weights are placed not at the same place. Let us consider the weight of these four button-like things is m. In this case, m is closer to the center of the wheel. So here the radius is less. And in this case, the radius is more. Now, we know that moment of inertia is m into r in this case. So here in this case, as you have said, moment of inertia will be less than this wheel. If moment of inertia is less, that means I is less, then omega must be larger in case of this wheel than this wheel. And omega is nothing but the angular velocity. So this wheel, which is having weights nearer to the center, will have larger angular velocity than the other one. So it moves faster than the other one.
Well then, 20 points to the JC Bose team, and the next question goes to the team seated on my left. That's their first question, the CV Raman team.
Here I have two pulleys. This is one and this is the other. This pulley has larger radius than the one which is on my right. I am hanging two equal weights from the pulleys, but they are not in equilibrium. Okay? To bring them in equilibrium, I have to put some more weights here. Almost in equilibrium. The question is, why in this system the weights are not balanced?
Since this is a system of pulley, therefore we have to consider the torque acting upon the pulley.
Very good.
Now, when the weights are equal, then the weight, we know that torque is equal to radius into force, magnitude of the torque. Therefore, in the smaller in the pulley which has a smaller radius,
Yes.
although the force is small, force is equal in both in case of both the pulleys. The pulley having a smaller radius will experience a smaller torque acting upon it, and the pulley having a larger radius will experience a larger torque. Therefore, when the weights are equal, we found that the system was not in equilibrium.
Yes.
As the torque was unequal. But since we have added some new mass, some weights on the red object,
Yes.
red mass, then we find that the smaller radius has been compensated by the increase in the weight of the mass.
And by this way we have equalized
equated
the torque.
Torques acting on both the pulleys.
Very good. I have nothing more to add to his answer. Absolutely right answer. Very good.
Well done, CV Raman team. You get 20 points for that right answer. Dr. Sanapati, you said you have nothing to add. Is that true?
Yes, that's correct.
Well, then let's have another round of applause for them. Onwards to the third question in today's show. Welcome back to Quest. 20 points apiece. Third question is for the JC Bose team, Dr. Sanapati.
I have a colored liquid in this conical flask, and the color is pink. I'll say hello.
Hello, 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 hello. Hello, hello, hello.
Is it going to answer you, Dr. Stanapati?
No,
Not going to answer you.
I'm going to ask him the question. See, the color vanishes. Now this colorless, what is the reason?
So it's a solution of phenolphthalein which is pink in the basic medium, but when you are saying hello into that conical flask, carbon dioxide is coming out of your body into the flask, and it mixes with the water in the solution and producing carbonic acid. And as it neutralizes, and even with further addition of carbon dioxide, the medium turns acidic or totally neutralized. As in neutralized and acidic medium, phenolphthalein is colorless, so the color vanishes.
Your answer is absolutely right.
Wonderful answer there, Shomna. Well done.
But I only have to add one more point. You didn't say that the medium was alkaline. You didn't say, because phenolphthalein is colorless. So you have to say phenolphthalein was there in alkaline medium. And when I speak in it, carbon dioxide is liberated, and that forms carbonic acid, which neutralizes the base. That's why the color vanishes.
JCB Team picking up another 20 points. They move on to 40. And CV Raman Team is still on 20 as they await their next direct question. The fourth question, the last of the direct ones, is for the CV Raman Team.
I have two objects here. One is made out of mild steel, and the other one is made out of aluminium. But they are of equal weight. I have a spring balance here. It shows roughly 250 grams. If I try the other one, this also shows 250 grams. And I have kept it inside a beaker, but the beaker is not having anything, only air. I am pouring liquid in it. The weight is reduced to roughly 140 grams. I'll do the same experiment with the MS object. And in this case, the weight is 200 grams, though their weight in air was same. While inside the liquid, there is a change in their weight which are not equal. What is the reason for this?
Now both have equal masses.
Yes.
Both are equal in mass, but they have different volumes because aluminium has a lower density, so it's larger in size. So when we, now there is, according to Archimedes' principle, water or any fluid gives an upthrust to whatever displaces it, and this upthrust is equal to the mass of the volume it displaces. Now this aluminum cylinder has a greater volume, so it displaces a greater amount of water.
Yes.
And this greater amount of volume of water has a greater mass, and
Okay.
it provides a greater upthrust to this aluminum cylinder than that in case of the steel cylinder.
Right.
So for this reason, the aluminum cylinder, the mass is reduced in this case more. It is much this weight recorded in the in this case when inside the water, this aluminum has a lower mass than that in the iron steel case.
Once again, I have nothing more to add to his answer. Absolutely correct.
Let's have a big round of applause for them. Pratim, when Archimedes discovered this principle, While saying Eureka, he also took off his clothes. We thank you for keeping yours on. Well, all the same, you picked up 20 points for your team. Both teams now tied at 40 points apiece as we move into the fifth question, which is on the buzzer. We are into the final stretch of today's quiz. JCB's team and the CV Raman team are both tied neck to neck with 40 points apiece as we go into the fifth question of today's show, which is on the buzzer.
Ready? I'm going to show you how to light a candle, but in a different way. This is the normal way of lighting a candle. Now I am extinguishing this. Without touching the flame to the wick, I am lighting it. Once again. Tell me.
BD Memorial.
The first time we have to light the wick for
Yes.
the candle to be light.
Right,
But
the normal way.
yeah, but once it's extinguished, the candle vapors are still there. So
Candle vapor. What is that vapor?
the wax vapor, the wax vapor,
Okay.
So in actual burning is the vapors that actually burn. First the wax is melted and then the vapors burn, which
Yeah.
gives the light.
And that catches the fire to the
That
wick.
catches the fire
Very good.
for the
Second
next
case
time.
we already have the vapors there. Therefore
Yes,
we
in the
don't have
second
to
case,
light the wick.
vapor is already there, so you need not bring the stick nearer to the wick.
Yeah.
Very good. Right answer.
Big round of applause for them. Good answer, Arnab. You pick up 20 points for your team. The CV Raman team is now on 60 points, whereas JCB's team are still on 40. Next question, again on the buzzer.
I have two 100-watt bulbs here. These are connected to the mains, one directly and the other one through a diode. And as a result, we find one is glowing with brighter intensity than the other one. What is the function of the diode in reducing the intensity of light?
Sir, this is a two-way AC current.
Okay.
Now, in a two-way AC current,
What is two-way AC current?
sorry, in a two-way
AC
AC
itself
current.
is alternating
Sorry,
current.
I'm sorry. Yes, in an AC current, current passes from this wire to this wire, again this wire to this wire. Now, a diode lets current pass in only one way.
Okay.
Now, when current passes through the diode, when current passes in one direction, it can pass. But when AC current tries to pass in the other direction, it cannot pass.
Okay.
So,
Then
the current is, there is no current when the AC current tries to pass in the opposite direction. Now, when the bulb connected to the diode, when AC current tries to pass to the opposite direction, it does not get current. This reduces its intensity, but the AC current does not connected to the diode gets current all the time, gets full the current. No, intensity is not reduced.
okay,
that
okay.
No
You
part
are
of this
approaching the
cycle.
right answer. Okay, we gave them full marks for that.
Dr. Sanapati.
But I need to explain.
Dr. Sanapati, in this case, you literally have to throw more light on the matter.
Yes. As you have said, alternating current is passing through both the bulbs. In case of the bulb which is having greater intensity, this is connected directly to the mains. So we are getting the full glow of the bulb as we get at our home. In case of the other one, we have connected a diode here, that allows only 1/2 of the alternating current. Alternating current is a sinusoidal curve. The voltage varies sinusoidally. So once it goes to the positive side, and in next half of the cycle it goes to the other side. So we are allowing only one side of the alternating current to pass through the diode. In a sense, this becomes DC. Suppose in 1 second there are 50 cycles. So half of that will be cut off by the diode. So in 1 second, in this case, the bulb which is on my right, you are getting less current than the bulb which is on my left. And that's the reason for the reduced intensity.
Thank you for that explanation, Dr. Sanapati. We find Abhimanyu from Patha Bhavan, who is on the JCB team, is very clued into current affairs. Well done, Abhimanyu. You pick up 20 points for your team, 60 points apiece. Anything can happen as we go into the very last question of our show, Quest. It couldn't have gone better. Every question answered correctly, and both teams answering one question each on the buzzer. Scores even Steven, 60 points apiece. And the very final question in today's quiz.
I have lead nitrate in my left hand in a test tube, and I have potassium iodide in my right hand. I'm adding potassium iodide to lead nitrate. We get a yellow precipitate. What is this precipitate?
Lead iodide. Lead iodide.
Okay, that's right.
Yes.
But how can I make it dissolve in water? Tell me how we can dissolve this in water.
Potassium iodide. So we are adding excess of potassium iodide, and then we add water. So in presence of water, we'll get lead hydroxide and Ki3, which is dissolved in water. First iodine will be liberated from lead iodide as free iodine, but as iodine is insoluble in water, so iodine will react with potassium iodide to form complex Ki3, which will be dissolved in water. In that way we can dissolve iodine.
Well, there is a simpler way. Simply heat this. Due to heating, solubility will increase and it will dissolve in water. In any way, I am giving you full marks for the first part of the answer.
Do you want to add anything to that, Dr. Sanapati?
No, the answer is absolutely right.
Well, Shoma, you gave a very comprehensive answer and picked up the clincher. Another 20 points for your team, taking your team into the lead and winning today's contest. The final score tally, 80 points to the JCB team, the boys from Patha Bhavan, Kolkata, and 60 points to the boys from BD Memorial School, Kolkata. Well done all. We thank both teams for coming and participating in our show. Well done, boys. Let's have another round of applause for them. Well done. CV Raman team, you also did extremely well, just lost out very narrowly on the buzzer round. Give them a big round of applause, please. If you enjoyed watching our show, or if your school would like to participate in the same, please do write in to us. Our address is Quest, care of Doordarshan Kendra, Kolkata, 18/3 Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week at the same time with the same show with 2 new schools. Till then, it's goodbye from all the team at Quest.